welcome to engineering.com. If you're here to learn how engineers can more closely align great AI expectations with reality, you're in the right place. But before we get to today's webinar, some quick housekeeping. 3 things. 1, this presentation and any additional resources will be available for download in the resources widget. 2, if you have to leave for any reason, don't worry. This webinar will be available on demand at engineering.com. And finally, if you experience any technical issues today, just hit that refresh button and reload the page. That solves most problems. Our thanks to SimScale for sponsoring today's presentation. And now I'm pleased to introduce our expert speakers for the day. David Heine, co-founder and CEO of SimScale, and Neil Ashton, distinguished CAE product architect at NVIDIA. David, Neil, we're thrilled to have you with us today. Thanks for joining.
Thanks.
Now I'm going to quickly go over the agenda for today, and then I'll let David and Neil get their words in, get some intros. We'll start with some quick intros from David and Neil, and then we're going to explore the engineering AI gap. Now, I'm sure everyone here is familiar with AI and probably has some strong feelings about what it can and can't do. I've seen a lot of claims myself out there for how revolutionary AI is going to be, and I think there's clearly a ton of excitement about it. But on the ground for engineers, is it actually living up to expectations? I'm not so sure. But it's starting this year in particular to come out with more practical applications of AI in engineering. So we might be well on our way to bridging that engineering AI gap. But to speak more about that, I know that SimScale has recently conducted research about engineers' AI expectations and their actual use of the technology. So David and Neil are going to go through a preview of some key results of that research and hopefully illuminate for all of us what we can do to be moving in the right direction. After that, I believe David is going to go through a demo of what SimScale is doing for engineering AI. And we may have time for some questions at the end, but you should know that whenever you're watching this webinar, even if it's on demand, you're free to type your question in the question widget, and someone will get back to you with, hopefully, a satisfying answer. And with that, I'm going to pass it off to David. Take it away.
Michael, thanks a lot for hosting. Thanks a lot for having us. I'll keep the introduction very quick. So at SimScale, there's a couple of statistics about SimScale on the left. And the statistics there really maybe hopefully convey that we've been fortunate enough over the last couple of years to work with thousands of engineering organizations to help them deploy simulation and AI broader, earlier, and more aggressively into engineering workflows, ultimately in pursuit of faster innovation. And that's at the core what SimScale is about. We believe that the technology is already there to enable engineering teams to cut down engineering cycle time, if you will, from design to simulate to design and iterate from, depending on the industry, depending on the customer, from weeks now to seconds. And we're excited about this because it opens up entirely new opportunities. It opens up to rethink how engineering processes should look like. It opens up new opportunities of how engineering companies can conduct their business. And so hopefully today, with the research we're showing, we're excited to show this because we've been having naturally like dozens of those conversations each week with engineering leaders. And so we're excited that we have now also some more quantified, some more quantitative things to talk about when it comes to deploying AI into engineering workflows. And with that, Neil, can I quickly ask you for a quick introduction?
Yeah, sure. Well, first, great to be on the call with you. NVIDIA and SimScale work really closely together, and particularly on this physics AI topic. So it's great to, I think, we'll be able to talk about some of that stuff a little bit later. But yeah, I'd say I come from a similar background, being an engineer. I've used CFD and these methods to design things and research things. So I fully understand the desire to always accelerate, go faster, do things faster, and do things more accurately. And I guess maybe just to say a few words about what NVIDIA is doing. Most people know NVIDIA for a GPU. And obviously, yes, that is one of the things that we make. But that maybe oversimplifies the sort of stack and the bit that goes into really accelerating all the stuff, to the point that probably the best case scenario is that by the end, the people on the top, the actual sort of ISV providers, don't need to worry about what goes on below, because we just make it work. So over the years, we've really focused now on a more full stack solution. So not just the GPU, but the CPU connected to the GPU, the networking, and then all these math libraries and tools that ultimately is all about helping companies like SimScale to deliver something better for you. And we just build those sort of building blocks that they can take. I think I could actually advance the slide myself. And one of the things that we put, and I guess we'll debate a little bit today on when some of these numbers can be true, when there are more nuances and challenges. But I like this slide because it just approximately gives a sense of why some of this sort of AI physics of interest. You could say that wind tunnels or physical testing was the stuff you might do on a weekly basis. And relative to that, whether it's a week or longer or shorter, relative simulations have allowed us to reduce that probably by an order of magnitude, where you can do things much faster in essentially a day. And we all know that things like CFD and FEA have tremendous advantages over physical testing, not to replace physical testing in its entirety, of course, but to make people to be able to design products and look at decisions much quicker. You could then say that, through the NVIDIA stack, if you can accelerate those, you can do more of them. You can run all those simulations faster. But there has become a point where just throwing more HPC or even faster GPUs reaches a point of scalability where, due to the underlying numerical schemes, you cannot achieve a sort of real-time delivery. And I think that is where the AI has this very unique use case of being able to deliver real-time predictions. And I always stress, it's not the point of this curve is not to suggest that you go higher and higher up the right and therefore you don't use the stuff on the left. That would be the wrong interpretation. It's ultimately going to be a combination of them. But the reality, and I guess the high level, is that the AI physics should enable you to do almost real time, which if you have a process that is streamlined and has a nice workflow, like SimScale has, then you could actually push through enough geometries to actually, look at maybe tens of thousands in a day. And that was all I had on the 2 slides. I couldn't remember how many slides I put in there. But yeah, anyway, we don't want to make this, too much of a sales pitch. So I only just wanted a couple of slides just to set the scene, I guess.
Oh, Neil, and great to have you. Thanks for joining us here. And I'm looking forward to riff a bit on and just to talk about shop on AI, physics, engineering, simulation over the next couple of minutes. I guess I'll take it from here really quick to introduce the research we've commissioned, and really where, a few words about why we've done that. And at SimScale, we've built for years a cloud native engineering simulation stack with the conviction that simulation should go away from a siloed function, or even put it differently, that there's still hundreds of engineers making design decisions and very few engineers evaluating design decisions in a modern engineering organization, even in the largest ones. And that we believe that in the future, the engineering organizations that will win will be able to evaluate design decisions as they are making them in seconds. And so where we select for that, simulation needs to be broader deployed, more aggressively, HPC provisioning, all of that good stuff. Now, and over time, it got clear sort of the data that is being collected, engineering data, past engineering data, will be used to accelerate or even automate future engineering decisions. And so we've introduced the first physics AI capabilities 2 to 3 years ago. And over time, sort of with the advent of LLMs and agentic AI sort of really sort of showing its power, it became clearer that sort of what we're seeing here is that we believe that AI will significantly change how core engineering workflows will look like, and to the point where an engineer goes very, very high level and interacts with at a very high level with systems, with computerized and AI systems below, and will only guide. And a lot of the busy work, literally drawing the line, deciding where's steel and no steel, will be handled differently. And so that's why we're putting this sometimes this very provocative, if you will, this provocative slide here, sort of prompting core engineering workflows. And we think the technology is already there. It just needs to go from the lab into the loop. And the way we think about it is that it's not going to look like, because over the last 2 years, when we talk with engineering leaders like dozens of times a week, the conversation we typically have is that most of the engineering teams will say use already some sort of AI system on a day-to-day basis for writing code, for research. Some of them have nice workflows in place around compliance validation, regulatory research, and the likes. Right? We've all using them, all white-collar jobs, all knowledge workers sort of like see this happening. And here's a little chart. I mean, it's probably outdated by now. Probably there's more large transformer models by now, but everything goes to the top right. They're getting smarter and smarter on a day-to-day basis. So the question could be, will there be a very large AI system, as the likes of the large transformer models that we're using today, that is actually will do, core engineering work out of the box? Frankly, I'm not going to bet against it. Could be, right? So maybe eventually it'll be there. So I don't want to bet against it, but the road looks tough there, because stating the obvious, the large transformer models have been trained on gigabytes, terabytes of publicly available data. The formats are very standard, yada yada yada. There is no equivalent of that in engineering data. Probably everybody in the audience that thinks about their AI strategy is clear about that. Typically, to begin with, the data is proprietary, sitting in silos, not shared. Second, it's in proprietary formats. Getting it out there, sort of even streamlining it, configuring to do something with it is tricky. And then lastly, even if you get it out there, is the data you actually want to train on? Should it be used to build AI models? So that's why we think, again, I don't want to bet against the big public engineering AI that eventually will come. We think what will come sooner is a more as a smaller approach. That is, that AI systems will emerge, or frankly have emerged, that accelerate or even automate parts of the engineering process. At least in Germany, a lot of people talk about the V diagram, from you've probably heard the engineering V diagram going from requirements and then system up and down. I like to call this the poor man's V diagram, because it's linear, it's much simpler, but it's sort of, conceptually conveys the engineering process from requirements all the way to manufacturing release. In an ideal world, it would be just like this, as streamlines. But everybody in the audience knows there's a lot of back and forth, there's a lot of iterations, there's a lot of loops, depending from where to where. So you might go between concept to detail design, back and forth. You might go from testing back, etc. So there's a lot of loops. And again, as probably everybody in the audience knows from their own experiences, some of those loops can take weeks. And not because, I don't know, the test takes this long, or the simulation takes that long, or the review takes that long, because simply stuff waits in Outlook, stuff waits in spreadsheets, stuff waits for the next meeting, etc. And so we think like a very simple way to think about this is, okay, now agentic AI systems are here, right? They are standard in marketing, they're standard in sales, legal, and now eventually they will enter this world. And so every step of this process, where there is some, again, some data is transferred, some decisions have to be made, there will, and frankly, there's a lot of exciting companies, a lot of products already out there that work on many different and propose many different AI systems that work on this. And the reason why we're showing the slide is that SimScale is not everything to everyone, or doesn't want to be everything to everyone. We're focused on this core part of the workflow where you have where a design has been authored, and it can be an early design, it can be a detailed design, it doesn't matter too much, but some design has been authored with some shape, in some shape or form, and this design is being evaluated, and there's now an iterative cycle. And we think the technology is there, and we're going to discuss it today and show it also by the end, that you can cut down this cycle that in some organizations and some teams take weeks, can be cut down to seconds. And we call the two AI systems we've built to that end engineering AI to automate the manual parts, and then physics AI, as Neil already alluded to cut down the solve time from, could be weeks or at least hours down to seconds. And we think the combination of both is what can cut down the engineering cycle down to seconds. We're going to go more into details with this. The reason why I'm sharing this perspective is the research we commissioned, and what we're going to sort of talk about now focuses on that. So we've talked And we've talked little to folks deep into systems engineering. We've talked little to manufacturing experts or quality leaders and the likes. We really talked to either CTOs, of course, that oversee it all, VP engineering, simulation leaders, so the folks that are primarily in the blue bucket, just to provide the context as to when we now go through those questions and discuss them, that what we're talking about and that sort of how it conveys to you. Because depending on, again, in the audience, when we talk with folks that own the AI strategy in their engineering organizations, some oversee it for all of those parts, some only oversee it for simulation, some are approaching it, some frankly live in IT, others are actually in OT. So there's different organizational patterns we're seeing on a weekly basis. And so I just want to provide that context to make more sense of sort of the findings that we're going to share. Neil, Michael, this was 10,000 words a minute, so I hope you're still sort of.
No, this is good.
Okay, so then let's dig in.
One point, David, there. This was a trend that I was hearing about for years before AI really entered the scene. Was this idea of democratization of simulation? This idea to bring the design and the simulation kind of closer and closer together, let designers use simulation more. The idea then was about simplifying the tools, making them more accessible. And so it seems to me that AI now offers the potential to sort of supercharge that again and maybe completely merge these two functions. Do you see that same thing?
100%. I mean, before, I mean, I don't want to ramble too much about this, but yeah, like a resounding yes, because we've seen different strategies when it comes to, because every engineering leader you ask, of course they want to simulate more, right? Of course they want to simulate faster. Of course they want to do that, but there were different strategies. Some banked a lot on automation, like investing more and more into SPDM systems, automation, and try to automate the heck out of it. On the other side, some bank more on democratizations and everything in between, where you deploy more broadly and sort of do more education. We think the advent of agentic AI, I mean, it says it at the bottom, where that goes from rigid automation towards true autonomy, but to some extent guided autonomy, where you can, give an agent or an agentic AI multiple agents sort of directions and sort of give it guardrails. And so a resounding yes. I will also say, I mean, we're going to discuss this now for the next minutes. I will also say, I think a lot of dust still has to settle, right? There's a lot of different technologies. I mean, we ourselves, I can share a few anecdotes and what we built, and then sort of how we got surprised by what suddenly the large transformer models were capable of doing, and it sort of eliminated stuff, frankly, we had built. And so I think a lot of dust still has to settle. Or also NVIDIA, with Neil here, sort of the awesome work they're doing and putting stuff out there. So again, I think a lot of dust still has to settle, and we're going to see what it will look like. But we're going back to the initial sentence of saying it's already here. It just needs to go from the lab into the loop. All right. Then quickly digging in to not run over time here. And then hopefully this is the context of the research we've commissioned. We've been working with having dozens of conversations each week now for the last 1.5 years, almost, probably more, around primarily about AI deployment in the area that we just alluded to. And we learned firsthand a lot of sort of concerns or use cases people are particularly excited about, or questions they asked us, or frankly, a lot of things we've learned from engaging in those rollouts with customers. And so we had a lot of anecdotes already, but it was nice then sort of to actually say, look, let's gather some data. Let's sort of show not just our anecdotal evidence, but also some actual sort of responses from the field to see what engineering or leaders of engineering organizations that are exploring AI for design and simulation sort of think and what they came back with. And here you see a few of the, with surveyed from. I mean, SimScale is Germany-based, which is why probably Germany is overrepresented down there. But other than that, it's in the main markets we serve. And I'll direct it again. It's a preview of the research we're gonna launch the full report in about I think 1 week or 10 days, something like this. I think we're gonna send it to everybody in the audience. So it's really a first preview that we'll give here. There's more to uncover in the actual report, But one of the questions we've asked is when we engage with engineering leaders, we ask them, okay, look, AI can do a lot of things, but frankly, it starts with what is the business impact you're looking for? What is the impact you actually, looking for your organization? And we found it interesting that really depending on the industry and depending on what situation the company is in, some immediately think about efficiency, as in, same result with less resources. But the bigger majority, which we can see here, is thinking about the top line impact as to how can we, the trifecta, better product to market faster. And so that's what most of them sort of came back to and sort of said, this is what we want to map out. And the interesting thing about it is that we actually think while the top line impact use cases are the ones that are more exciting, that are typically sort of internally needs to be budget allocated to it. It's the more excited use cases, but more often than not, what we found is that it automatically also brings efficiency gains because, you're not just running way more iterations, you're also running them with less, time on task. And that's sort of, I guess, one of the aspects that the big majority is looking for top line impact, and not when you think about automation, it's about efficiency. Was an interesting finding. We've heard it multiple times already, but sort of the data also clearly shows it.
Yeah, I think that's certainly, I think, a wise observation in the sense that only doing AI to reduce costs in the context of maybe physics AI, I guess ultimately maybe the costs may come down or certainly the margin, maybe that seems more logical. But I think the honest truth is there does need to be often some investment to reap that. So I think just trying to only see it as a reduced cost, at least in a short term, is probably not the right way, partially because you need to, hire skilled people, you need to invest, you maybe need to generate more data. I think it's interesting that this actually, it's reassuring in the sense that I think a lot of people more focus, which I would agree in, which is the design innovation, that really what the AI should be able to give you, at least in the context of more, I guess, the physics AI bit that we were discussing, is that you could potentially explore a bigger design space. And because of that, and because you weren't limited to only 100 designs, but you could look at 1,000, maybe you've now found a better innovation, which allows you to then deliver something that beats your competitors, and then that ultimately brings in the money. Whereas if you just said, yeah, but the physics AI now runs 10 times faster, and therefore I can save money, that seems... So it's reassuring that your highest percentage agrees, at least with what I've been thinking.
And I would add, we also know from reality that sometimes to convince the stakeholder in IT or the stakeholder in finance, there might have to be eventually a cost efficiency calculation as well, but it's typically not the point you want to start with. Specifically because the excitement of the business case only with cost efficiency, as you said, Neil, is typically, you want to do this for that. It's typically not as exciting as what would, a significant percentage in performance improvement of your product actually mean to your top line. It's not as tangible as cost savings, but that's the one you want to start with.
Agreed.
Good. Looking at the time, let's flip further. Here's sometimes internally we say that's the Captain Obvious finding here, but it's probably among, I like that this is in this data set, because but many engineering leaders are under a lot of pressure from different stakeholders to actually define how AI in their engineering workflows will look like, what it will mean, where it is being used. And given not just is it new technology, but it's also changing on a weekly basis. And I mean, Neil, it's you and my job to sort of stay on top of this stuff. And so for us, it's challenging to stay on top of this field. But then let alone if it's not your full-time job, I mean, it's even more challenging. And I like this statistic, which essentially says, look, yes, everybody the number of skeptics that don't think AI will have a massive impact on how they engineer is very low. So everybody knows this is coming. We can see at the bottom sort of what it could deliver. The blue part, some have very high expectations or sort of what will come. Green is sort of, not as high, but, significant impact, which is why, frankly, they're exploring is, which is why they're all over this. But then the top chart shows the actual reality, that everybody is at the beginning. And it's no wonder, because, again, seeing an AI application update something, no offense, but update something in CRM and sort of, doing a bit of business logic is just a different beast to actually weaving it into an engineering workflow that has been calibrated for years, where, frankly, litigation is at play, where lots of downstream processes are at play. It's a different beast. And so I found it reassuring that, look, everybody is in this is in the same situation, and so that's why we think like also putting this out there, putting some research out there, helping facilitate those conversations felt like the right thing to do. So I like that this is one of the findings.
Yeah, and I think probably one of the challenges that we have is that there is a quite a gap between the effectiveness and the productivity gains from some AI use cases and what is the AI for engineering use case. And so if you go and use one of the large language models now to go and help write, a blog or summarize a paper or do it, I personally find them, or even write some code, I find them extremely good. And I genuinely find a huge productivity gain than if I had just searched forums to try and, write this bit of code. So naturally, you then expect, well, surely AI for engineering should be able to give me the same productivity gains. And I feel that, one, it's a reasonable expectation, but it's just unrealistic given the maturity and, frankly, how it's more challenging. The AI for science in more general, if we expand this, is a hot topic that everybody understands is probably years behind the more, enterprise AI, I guess you would call it. So I would just say that it's just having the patience that I have no doubt whatsoever that the productivity gains from engineering AI will increase month over month, year over year, but it is probably just lagged behind, and people just need to realize that and not, give up, I guess. But I'm actually pleased that what you're showing, because there are still skeptics out there, and every time I see a skeptic, I sort of feel sorry for them because I'm almost like, well, okay, I could be wrong as well, but I don't know. I always feel like have a positivity, have a you've got to almost, if you just look at all these new technologies and think they're just marketing hype and all that, I don't think that's the right mentality to have.
And it's a bit of a danger in this conversation because obviously this is a bit of an echo chamber of AI for engineering. So it is a bit of an echo chamber, but I agree with that. And maybe in no doubt there's a lot of signal versus noise right now there, and it's hard to differentiate signal from noise. There is marketing hype versus and vaporware, but I agree with that some of the stuff still has to catch up. But I think what I find good is like, I'm not sure how it feels to you, but 2 years ago, like the large transformer language models came out, there were way more skeptics. And so now I feel like it's more a conversation of how aggressive, with how much budget, with how much dedication, with how much headcount are we pursuing this, and what's the right approach, right? Is it an IT? We see it sometimes IT initiative, OT initiative. Sometimes it's more like bottom up, top down. So I feel like this is changing month over month, and hopefully this, frankly, this webinar and this content maybe helps to advance this conversation further.
And I should say as well that I'm not just saying this, in a pub conversation, just as an opinion. I have a fortunate position to speak, to hundreds of customers. And so I can see the gains, and I'm also aware of enough of the development and research to see it. So I'd like to think that what we're both saying is not pure opinion and pure just pub talk, but is actually from seeing stuff that maybe people in the audience don't themselves see. And so Yeah, it means you have to trust us a little bit, but yeah, that's what we're asking. Yeah.
It could be a title for a follow-up webinar, Engineering AI Pop Talk, Neil.
Yeah.
I'll follow up on that via email. Okay, just moving on here, looking at the time. Also, maybe between Captain Obvious but also linking to the one before, our sort of we almost said it, right? Most of the organizations at the very beginning of this, we just seen it earlier, 3% have already adopted it, and the tricky bit with this research is we commissioned it, so it's not like ours, like somebody else did it. But of course, sort of the findings here are, Captain Obvious, okay, cloud native makes some things easier. And the anecdotes I will put out there is like, unfortunately, or what means unfortunately, but engineering organizations, most mature, large engineering organizations have been around for decades, have produced a lot of data, have a lot of legacy workflows. So it's not that easy to just like, move everything to the cloud and we're done. This is a bigger topic. The way we engage with customers is typically sort of SimScale works out of the box, like, vertical stack, end to end. You have a mature way to deploy a physics AI model, engineering AI model, all the way down to sort of provisioning the GPUs automatically. And so, yes, of course, that allows a company to say, hey, look, we have a couple of thousand simulations already in SimScale in the cloud sitting on this mature stack, so we might as well explore this. And so, yes, that's a bit sort of, the statistics that show stuff in our favor of the work we do. But again, there's also other cloud companies out there. I guess the main takeaway here is that we think that engineering organizations wanted to deploy what Michael said earlier, simulation broadly for a while, and arguably there was some progress made for sure, but to a large extent it's still an expert function in a siloed way, and so. And it's because it's just not easy. Stacks have been built for decades with a lens on physics, not with a lens of how can we deploy this enterprise-wide. And so the same challenge got now sort of intensified because now it's not just as deploy basically solvers, but actually now manage the data in a way where you can train models, where you have visibility in how those models were trained, where you ideally log, where you have traceability, where you have deployment control, where you conversion. There's so much additional IT complexity that comes into play that we think, again, it's not as simple to just like, hey, look, let's go to the cloud and problems are solved. But indeed, the challenge around like what stack are you deploying this all on and what's the IT strategy behind it just got more intense. And that's sort of hopefully at least one statistic here that gets people think about that.
Yeah, well, I've always said that in some ways the benefit of using a SaaS-like platform like SimScale is, I always thought that the AI use case was the bit that makes it even more sense in the sense for the customer, because to build, I mean, everybody to their own, of course. Some people decide not to use cloud native tools, and if you do, that's fine. But there is a certain advantage. I guess you as a company can more easily integrate modern LLMs because you are based on a cloud stack, so you can more easily integrate and take the APIs and pull in services from various cloud providers. And then as an end user, you can take advantage of it being a bit more seamless and not having to have this installed with this on this operating system and with this. So I can definitely see how the cloud native tech stack becomes even more advantageous when you're looking to use AI. It's still advantageous even without, doing it through a web browser and things like that's all great. But then when you want to add the AI into it, I feel like it makes even more sense, both on you as a company and as the end user. It's a sort of win-win, I guess.
Can I step in then with one objection that I commonly hear from a lot of people? Maybe not an objection, but just a sort of niggling concern. People have always been a little bit wary of the cloud, some people anyways, because they're worried about their data, their IP, as we hear all the time now. But you bring AI into it and people are getting even more concerned. Well, hold on, now I'm not just worried about my data being stolen, I'm worried about it being stolen and used to train an AI model that I have no control over. So what do you say to that? I'm sure you get that question.
Yep. So it's almost at this point where sort of with the types of deploys and with the types of customers we work with, we think every customer will have the data strategy. Every customer will have their deployment strategy. And for good or not good reasons, that doesn't matter. But they will have that. And so to some extent, I think if you're building engineering software, you need to, in some shape or form, embrace that. And so where I'm going with this is, if a company is ready to go, like, engages with us at SimScale, we can provide a physics AI model on day one. And literally on day one, when they start, they can have a physics AI model, everything is taken care of. If they decide to not want to go full cloud, there's other options that will take longer, realistically, to do that. But where there's now shades of gray on different deployment models. And so I do think at the end of the day, it's a trade-off that the organization has to make, that the engineering organization has to make. And I will say that I think typically it's also a bit of a process, right? As in, let's bolt on. Like ideally, there was for a long time, there was or I guess there's still the idea of lift and shift. So we don't change our processes and we just shift it somewhere to get more compute. Now, I'm not sure what the new terminology might be, but something like lift and shift to AI or bolt on AI, or like just have the stack and just like have AI sort of weave into it. And what we typically say is, with enough time and money, that might work, right? But the tricky bit is there's very few engineering organizations that have enough time and money. And so that's why at the end of the day, it comes down to a trade-off. And the companies that are more willing to basically embrace maybe another generation of tools or another generation of deploying these things will reap benefits earlier, again, for certain workflows. So that was a very political answer, Michael. But
I'd say as well,
a very diplomatic answer. Sorry.
I think there's a difference between security and sovereignty. I think there's been plenty of public blogs put out there by very established people in government, in security agencies, who have publicly said and stated that they believe the cloud is more secure than on-prem. So there's many examples. You look at any cloud provider and you look at some of their top users, security is concerned. So I think that is a little bit like the AI question. It's almost an emotive thing, a little bit. I think sometimes that sense of cloud and that I can't see it or whatever, I feel it's more of an emotive. Normally, you really want to get down to what specifically are you worried about? And then the conversation changes. If it's just an emotive feeling or sense of, somehow I'm a bit worried about something, that's fine. You respect people's emotions. But normally when you drill into it, they start to go away. And to be fair, there's been a lot of investment by all the cloud providers and your company themselves to do that.
And I guess, Michael, where I agree with you, this cycle is now a bit refreshed, right? Because a lot of companies, a lot of the largest OEMs on earth have sort of made, publicly stated the adoption of cloud. And there was a lot of, readiness to do that. AI basically in a new cycle where people first need to get comfortable again with it. Looking at the time, I guess we need to advance here, even though it's a lot of fun to discuss. So we have 3 more findings ahead. We talked about, current adoption is not, expectations and reality is different. Adoption is not very high. This is the segue into, how prepared are you? And I think we're almost don't have to go deep into this because it links very much to the discussion we just had before. We talked about people don't know really what to do. People don't have a lot of clarity. And this one is people have a somewhat prepared idea what they will get. And it just adds to this, I guess, to the statistic around, or to the fact that a lot of engineering leaders are really at orienting themselves. Let's put it this way. And again, why we wanted to put this together and at least show a bit how we think about it and help in that orientation. I'm not sure, Neil, Michael, if you had any further thoughts here.
No, I think, that's, I guess, why we're having this webinar. I think, people ultimately just need to educate. There is a matter of hiring as well, hiring the right people with the skills background. But probably people only feel somewhat prepared because it is just so new. And I think that's okay to feel that way. probably most other companies feel that way as well. So you're not alone. And I guess that's maybe the reassuring thing when you see these statistics is you may go, oh, I felt like I'm not that prepared. Oh, luckily 73% also feel that way. So yeah, this is quite common. This doesn't surprise me, I'd say.
Yep. Me neither. And I think it reflects very much sort of the conversations we have coming in. I think here we probably mostly discuss this as well. What I will say here is this, I think, shifted from 2 years ago. I would say the skeptics, Neil and me riffed on this like, I don't know, 10 minutes ago. There were a lot of skeptics and, there might be just cultural or organizational resistance to embrace this. It's not anymore, right? We've seen it earlier, 93 sort of expect this to have an impact. But yes, the same reasons that, kept data from flowing freely from siloed, tools along the PLM landscape, it's the same problems that now prevent data from flowing freely and maturely, compare the hardware engineering stack and the software engineering stack. From flowing freely and sort of blocks that. And so here's on the right, obviously the one we like to see is the desktop CA part that blocks people, but the other ones are sort of, for us, the main point is like, it's not cultural anymore, it's not organizational anymore, it's really technical readiness to embrace these new technologies.
Yeah, I mean, all of these, I mean, they all are very valid barriers, and I guess each of them is probably dependent on the company and the use case to some extent, but the data side is clearly, I would say, still probably the biggest barrier at the moment. And maybe this is a segue later. I think we may discuss it, some of the sort of foundation models, because assuming that everybody's going to have to train their own model, obviously then does require people to have their own data. One of the, I think it's still early days to know how widespread this will be. But I think one of the things that we've done together is explore more the concept of foundational models. And this very nicely links to this in the sense, the whole point of a foundation model is it's pre-trained. So by definition, you don't need to have the trained data yourself because, in this case, SimScale have already trained it. Okay, maybe you could fine tune, in the future, bring a little bit of data in, but that's something to bear in mind as, people hear these topics of models and foundational models, because if data truly is one of the biggest bottlenecks, it motivates the idea to explore more of the foundational model route. So yeah, this is interesting. I like this data actually. I'm going to have to look at it a bit more closely after this webinar myself.
It's a preview, Neil. So you're going to get the full report soon. Complimentary in your inbox. Good. Oh, two more, and I think specifically the last one I thought was interesting. I think we covered this one. It's just in more detail, as in, okay, who are the ones that are confident around, getting where they want to go? Again, the readiness of the IT stack, the readiness of how data process and user management is done, the readiness of how HPC provisioning is done, plays into that. Again, translates into higher confidence of the folks that are in a more modern stack. Again, doesn't solve it all, because we know that not all legacy workflows can be just migrated in an easy way. Some of them you don't want to migrate, but at the very least, it stresses the fact that there's no AI without the right foundation. And here we see it, I guess, also confirmed from statistically.
I wonder if some of this is a little bit of a cultural thing, in that if AI itself, many of the AI startups were sort of cloud native. Now, some of that's changed a little bit because, some cloud, not cloud providers, some AI companies are so massive that they are almost now their own cloud. And so, technically they're on-prem in a way.
Right.
But, everybody's on-prem to some extent. A cloud provider is on-prem technically, I guess. Just
the cloud is out of people's computers. Yes.
Yeah, we don't need to go into that sort of thing, but I think that actually shows more of a willingness to embrace new technologies, is the way I would interpret this. That if you are the sort of company who is not willing to investigate the cloud or use some cloud native tools, you may have that same mindset that you see AI also as something a bit new, and I'm not sure I want to test it. So I kind of understand why it makes sense to me that there would be some link to a cloud native mindset and a faster adoption of AI. It feels like they're a similar sort of new technology thing, and I can imagine that people who are maybe more skeptical of the cloud may also have that same sort of not willing to look at new things. I mean, we have to understand some people have valid reasons for being in the cloud, not on the cloud, but I can sense why that. I can understand where these numbers would come from.
And what I will add, Neil, maybe before we wrap it up, on the finding side, and just quickly go into a quick demo. Our conversation has also changed a bit as it relates to. At the end of the day, what we're building is like an open cloud platform, and so there's added shades of grace for specific workflows. And where I very much agree with you, Neil, is that I think like thinking that one can be fast without any type of leveraging external infrastructure, leveraging external sort of some already vertically integrated aspects, I think is probably unrealistic. I agree with that. But there's shades of grays as to which workflows. That doesn't mean like you need to move everything, right? There's sometimes greenfield projects, innovation departments. There's many different ways how we are seeing customers embrace that. We haven't talked about sort of third-party data ingestion versus sort of vertical integration. So we're seeing at this point there's very rarely a company that that says no, like absolutely no cloud. They exist, but very few. But there's all sorts of shades of grays to which level of aggressiveness they do it. And we think there can be, there's workflows or projects or departments where you can explore it very, very rapidly, much faster that way. But then sort of take more of your time with more critical workflows. Okay, just wrapping this up with an eye at a time. The last one. We thought again the cultural aspect became less of a thing, frankly, over the last few years, and we realized this anecdotally. Everybody embraced it. We thought an interesting finding was that actually the internal perception of cultural readiness, of sort of internal resistance to change workflows, was high among very senior leaders, lower among engineers. And the funny thing was that we don't necessarily, this doesn't necessarily map. We felt both are very open. So on both levels, we've seen openness to it. So it was interesting that the internal perception doesn't map that. What it means culturally, we thought like it's an interesting finding. We'll present it here to the audience and see how they map this to their organization. Good. I'll quickly wrap this up, Anil, and let you chip in. I think I guess the full report that we're going to send in a week will have more detail. We thought these are interesting, almost like sound bites that we can pull out. Now, mapping this to here's just the top 5 checklist that you need to check, and then sort of, you have your AI roadmap figured out, would not do justice to the complexity of the topic. But we thought at least sort of the stab at sort of summarizing this is, I think we covered this enough that sort of a modern without some level of investment into modernizing architecture, and again, doesn't mean all cloud, doesn't mean sort of, binary decisions, but in some shape or form, embracing that deploying this technology comes with significant new complexities, and bolting on, will be tricky with enough money and time, so there will be a modernization needed. We're going to dig in the last 10 minutes quickly into, from our perspective, the differences between agentic AI for engineering, we call it engineering AI, and physics AI, sort of accelerating the simulation workflow. Specifically on the agentic side, we expect many vendors to provide agents. We see the most mature companies actually thinking about their own agent orchestrations, and we think that's needed. So it has nothing to do with SimScale in this case, but in a way, I like the terminology. The old scripting is the new prompting. And so in a way, you will always had your own scripts, you always had your own automation, you always had your own tooling, and so you will need your own agents. And so we are actually now entering customer organizations that have already agentic workflows, business process, agent orchestration in place. Also here, to be honest, we see a lot of noise in the market. So there's a lot of software vendors, and it's not clear where this will go and which ones will go into engineering. But that is to say that the engineering AI we will show is weaving deep into SimScale and provides agentic workflows to SimScale. but this agent will have to interact with others that you control. The thing, and it connects a bit to the first one, is we actively had CTOs tell us they are sick and tired of POCs. That, like we heard the terminology of orphaned POCs. That doesn't mean like POCs are bad. It's more like we heard the terminology of orphaned POCs in the lab. Nothing wrong with POCs, but if afterwards it's not entirely clear how this will be deployed into mature workflow, versioned, commissioning, pricing, yada yada yada, it's tricky. And the last mini thing is, and it also connects to the first one. It's almost in software engineering when we're a software organization that writes software for hardware engineers, and so that's why it's fertile ground sort of from compares how a software engineer works to how a hardware engineer works, and how the IT stack supports it. And we do think like many of the software engineering best practices will have to enter the hardware engineering software stack in order to actually do that. And that's why infrastructure as code is normal in software engineering, and so now we're entering sort of this hygiene, and these things are like will become important. And I think this is the type of thoughts and the type of discussions that we think like comes out from this. And I guess like the research piece to conclude is from our point of view is like, I think the engineering community has understood, most engineering leaders have understood this technology is not a fad. This technology is not like marketing vaporware. This will change how they work. And it's about getting ready for it. And it wouldn't do the complexity of this topic justice to just say, here's a couple of things you just need to take care of. It's just like maybe a small summary, and I think a mindset that we suggest having when approaching this.
Yeah, no, completely agree. Yep.
Good. Michael, do we have time? How much time do we have left? Just quick time check before we.
We've got just under 10 minutes, so if you can do a speed run of your demo, that'd be great.
Maybe just to round it out, because so far, we talked about engineering, we talked about physics AI, maybe quickly showing how we are approaching this and how this works in SimScale. I'll try to keep it very, very brief. And I want to remind everybody of this little, the engineering process, and then in the middle of the box, sort of this is what we're focusing on. There's many AI systems that emerge, but the one we're working on, we think that to get the design cycle time, so from design author to simulated down to seconds, 2 AI systems are needed. And the way we think about it is there's in some shape or form some intent always appears that the engineer takes, and typically a human engineer sits down, drafts a design, hands it off to somebody that can evaluate that design. That loop goes on a couple of times, depending on how much time you have, pencils down, you have a result. Very simplified view of this world. The way we think now the AI will able to sort of impact this is 2 systems that we're building. We've woven the large transformer models deep into the SimScale stack to provide agentic workflows out of the box, so that you can basically go into SimScale and have some work inside SimScale done by an agent. We're going to see it if Michael, as the timekeeper, allows us. We're going to see it in action in a second, just for a minute. And then the second point Neil mentioned, alluded to, is the ability to use past simulation data to predict future simulation results in seconds, based on inference, not on a solver. And so all of this is agnostic to the type of authoring technology, the type of CAD system, the type of BREP, whatever system you're using. And so by that, like closing the loop on this, we think like seconds become feasible. And so I just want to give you a gist. I'll invite everybody, obviously, if you want to take a look at yourself at SimScale, feel free to do so. But I'll just show the 2 systems in action in a second. I'll quickly hop over. Michael, Neil, can you confirm that you're seeing SimScale?
Yep.
Okay. And so the first one, this is, we don't have time to explore everything around SimScale, how SimScale does user management. We can see here AI model management, how we manage data on SimScale, etc. We just want to quickly show the 2 AI systems in seconds. Neil, can you see a pump?
I see a pump. Mm-hmm.
Okay, good. So we're using basically SimScale's ability to manage simulation templates. It's a pump. I just made a design change to this pump, and I want to quickly evaluate sort of the performance of it. We're going to use the template management capabilities of SimScale, bring in a fitting template that is used to simulate this pump. So you can see it comes with a with the example geometry. Can you confirm that you're seeing sort of the difference between the new and the old geometry? Sort of the new one has a longer outlet, different number of blades. So we're going to apply the simulation to the new geometry and going to update this one. And what we can see is, so now we have the simulation basically ready for our new pump. And now we could run a normal standard CFD solve, right? I can press here on start. Could run it. Now we have a CFD simulation running, but frankly, that's going to take 20 minutes. And we just talked about, what about AI? So far, no AI. So what we can do now, and Neil alluded to, we have a pre-trained model for this that has been pre-trained on thousands of radial pumps that can now be applied to this exact setup. So you can see I activated a radial pump model that it has now been trained on these types of simulations. And so what I can see is I get within a second a simulation result, quickly confirming that you can see this as well.
Mm-hmm.
Right? And obviously now I can make changes to the the operating point. This is parameter free. I can now change the flow rate, could change the geometry, and would get real-time predictions of physics. Right? That's what we mean by sort of physics AI, the ability to immediately predict results. As Neil alluded to, we're currently looking at graphical inference. Right? So that's one use case, but obviously now what you want to do is explore optimization, aggressive use of optimization, design space explorations. It can be coupled to system level simulation and the likes. So that maybe quickly on physics AI. And then just quickly hopping over, looking at the time, because we just have 5 minutes left. Just confirming once more here the screen share. Do we all see a bike frame?
Mm-hmm. Yep.
Okay. And so now, because before what we saw, okay, this is how simulation time is cut down to seconds. And now what's basically out of the box possible on SimScale is that you can that we've woven large transformer models deep into SimScale, basically taught them topology, taught them how to use SimScale, taught them force and X direction or parts aluminium. No. Taught them how to use SimScale. To think about this is a very junior engineer. That's a demo agent. It hasn't been trained for any specific purpose. So it's just a demo. You can see on the left, the agent now has agency, can reason through the prompt of SimScale, can sort of knows how to use SimScale, knows how to set up the simulations, has seen thousands of simulations on SimScale, but of course is not particularly good at any one of those because it would need to, it's the same with the pre-trained models for the pump. It needs to first understand your organization's simulation best practices, how you want these things to work, how automatic versus non-automatic you want it. For example, if it stumbles now on anything, it'll come back, right, and ask. So you can instruct the agent to say how much it shall actually reason himself, etc. So hopefully, the whole concept here shows, again, we're looking at a very junior, simple agent. And to explore this in real-world engineering workflows, we can see, try harder. And so you can see now it comes back, an arrow, we could have set it up in a way that that it reasons through it, that it does this more automatically. It might not have seen enough simulations and the likes, but hopefully what it conveys here is, what it conveys here is that you have an agentic workflow already woven into SimScale. To make this usable for your specific type of workflow, it needs a certain level of adaptation to your specific workflow. But the future in which an agent is able to actually reason through simulation workflows is already here. And again, it just depends on what use case is most valuable to you. And so it then can sort of be deployed in a workflow that makes most sense to you. And hopefully the two things, mesh warning doesn't matter too much. And so, we're up and running with a simulation. So an agent just set up a simulation. Bringing it back maybe to the to the slide here, Michael, and then handing it back to you. Hopefully the little, what was this now, 4-minute a quick demo showed that the systems of being able to predict physics in seconds is already there. The fundamental technology of actually agentically reason through simulation setups, through result evaluation, through sort of typically very manual work that is associated with simulation setups is already there. Both what I showed, both were pre-trained, both were sort of, in a way, pre-trained models that might or might not be valuable out of the box to your organizations, to any specific organizations. But naturally, these models can be taken as baseline, trained on top, configured, fine-tuned, etc. And so the technology is there. It's a matter of actually sort of embracing it, seeing what is the biggest use case for your organization. And hopefully all of this, the research we've shown before, the little sort of tidbits of demo here shows that it's not something that is years out. It's something that can be pursued today. Michael, with that, I would give it back to you.
Thank you so much, David. Neil, I want to let you get in a last word, but we're going to have to save that for Neil's pub talk because we've got to end the webinar now. But it was great to have you both here. Thank you so much, David and Neil, for that presentation. Thank you to SimScale for sponsoring today's webinar, and thank you everyone for tuning in to learn a little bit more about design and engineering. Remember, this presentation will be available on demand on engineering.com, and you can ask questions at any time. Thanks for joining us, and have a great day.